In this example, it's going to be slightly different. So it's asking for the first 6 terms of this sequence, and this one is slightly different because it has an n squared in it. But that's not going to be too difficult. We just have to replace our n's with 1s for the first term. So to find the first term, it's u1. We would put 1 squared plus 1 minus 1, which is 1. For u2, this would be 2 squared. I'll write that in full. 2 squared plus 2 for the n here, minus 1. And I'll write that below. 4, 6, 5. For u3, you replace the n's with 3's. So 3 squared plus 3 minus 1, which is 9, 12, 11. u4 is the same. So 4 squared is 16, minus 4 is 12, plus 4 is 20, and then minus 1 would be 19. u5 is going to be 5 squared, which is 25, plus 5, which is 30, minus 1, which is 29. Oops, I'm running out of space here. Okay, there we go. And u6 I will have to do at the top. u6 is 6 squared plus 6, which is 42, minus 1, which is 41. Now, when you've got a lot of numbers written down here, if you did this in an exam or a test, the mark scheme would only have the numbers written in a list, and you probably want to do that and put a box around your answer. So you wouldn't move on to part B now. You'd write your answers like this: 1, 5, 11, 19, 29, 41, and then put a box around it because they are your numbers. You'd leave this here for your working out, just in case you made a mistake. So, for part B, calculate the first differences between the terms. So the first differences means the first row of differences. So I write the sequence out like so, and it's asking for the first differences. So the difference between 1 and 5 is 4, and then you have to add 6 to get 11, you'd have to add 8 to get 19, you'd have to add 10 to get 29, and you'd have to add 12 to get 41. Now, part C is then asking for you to comment on the results you obtain. So what comment could we make about these? Well, we would notice that the first differences are increasing by 2 every time. So the first differences are increasing by 2. I wonder how that affects things for the next example. It's asking us to calculate the first 5 terms of this quadratic sequence. What makes this quadratic? The word quadra is Latin to mean square, and this has an n squared term in it. This makes this sequence quadratic. If it doesn't have this and it's just n minus 2, for example, then that would be linear, and that's what we did in the previous videos. So to work out the first 5 of this sequence, u1, you're replacing the n with a 1, so it's 3 lots of 1 squared minus 1 minus 2. I'll write it underneath, put the equals in a line. So 3 minus 3 is 0. Okay, I have just given you the answers here because we've done this in the previous example. But our answers are for the first 5 terms written in this box. Now for part B, it's asking for us to find the first and second differences. So then the first differences, we could just write the sequence again, find the first differences, which in this case is 8, 14, 20, and 26. And then it's asking for the second differences, and that is the second row. And that, in this case, is 6, and 6, and 6. And this is now constant. Because the second differences are constant, we will be able to work with this, I believe. So it's given us in part C to comment on our results. We would say here that the second differences are a constant, which is 6. And this constant here is the important part, as you'll see in the next example.